Okay, so I'll give everyone a few more minutes to join in here, but as you can all see on our slide here, just in case anyone's gotten to this point and doesn't have it installed, please make sure you have 5.6 installed. Download the project files. Links are posted in the chat, as well as you should have gotten it in your email. And then if you can go ahead and open up the project and go to the obstacle course level, it should be in the workshop folder. And if you want, totally optional, but you can build a treehouse out of only primitive shapes. No actual static mesh is allowed. Oh yeah, I actually just commented about the UI switching in 5.6. I didn't know that until a few days ago, and I tried to switch this project to 5.6, and I was looking for buttons. Like, wait, where did it go? If you guys see me like looking for a button in the viewport, that's probably why they moved everything on us again every time. But if you've ever switched, like if you're someone who started working in Unreal and Unreal 4, and then the switch to 5 was really jarring, but if you ever try to go back and work in 4 now, the UI feels really off, you know? At least I run into that anytime I have to open a 4 project. Or I had opened Cascade the other day, actually, because it's something that hadn't been upgraded, and it was really weird to see the UI for that. So yeah, give it like 2 more minutes for people to join. But if everyone wants, like, I know we probably don't have time to do full instructions around the room, but if you want to like kind of type in your background and your experience with blueprints, and I guess both Unreal in general and then blueprints specifically in a message, that would be great. It'd give me kind of an idea of like what you might be familiar with and what you might not be familiar with in here. Okay, cool. So character artist, environment artist. If you're used to the material graph, I think blueprints is actually a little bit more straightforward. Like there's more options of what to do, but it's well, you're usually not dealing with lots and lots of inputs at once and lots of outputs at once. Uh, oh, hey, someone familiar with C++, cool. All right, so some of the info I might cover is going to be like more general introductory programming topics because that's relevant to blueprints. So it might be a little bit redundant for some of you, but please bear with me there. Sweet. Okay, I guess so. We're at 7 past now, so I'm gonna go ahead and get started so we can try to get to everything here. Looking at everyone's backgrounds, we do have a good mix. Lots of people with art backgrounds. One in there mentioned having C++ experience with material graphs. Some people worked in Unreal, like Unreal a little bit or a lot, like maybe some experience in blueprints, some like not at all. So I'm going to try to cater towards everyone. There might be some information that's like, I don't know. I'm going to try to go a nice average pace here. But yeah. So intro to blueprints. You can see my pro photoshopping skills here. So it seems like we're all set, but just to make sure, this whole workshop's going to cater towards people who have used Unreal at least a little bit. So like, you know how to create new projects, navigate the viewport, navigate the content browser, and like place and manipulate actors. And by manipulate, I mean like assign a different material, scale, rotate, move it. And so like you don't need to be an expert in it, but just knowing how to do that stuff is going to really help out here. Then what we're going to be covering today. So first, we'll just kind of have a general overview of what blueprints are, as well as like how to navigate the graph and a few things to keep your blueprint graphs organized, as well as some more like kind of stuff you would see in introductory CS class, almost kind of like programming but fundamentals. We'll have a snack break in there, and if you're stuck on any of the stuff we're making, the snack break is also the time for me to help you individually get unstuck on certain things. And then through the workshop, we'll be making hopefully 5. I don't know if we'll get to all 5 of them, but at least 4 different blueprints that are obstacles in like an obstacle course game. I've picked the structure in particular because if there's a chance where like you can't quite get one of your blueprints working, it's not like one big system tied together. They're each individual things. So like say you get stuck on something with a trampoline, you like there's a setting missing on a mesh or something, then even if that's broken, you can still just move on to the next exercise just fine, and we can come back to fix the trampoline later on. So yeah, we'll be making a basic kind of spinning obstacle, a trampoline that throws the player into the air, some sort of moving platform, moving sidewalk, what do they call them here? Travel somethings. I forget the British term for moving sidewalk. A bomb that chases people, and something that spawns like bouncy balls of death that fly around and hit you. So yeah, what are blueprints? It sounds like most of you already like kind of have worked on them a little bit, but we'll just cover this anyway. So blueprints are pretty much just a graph-based way to write code in Unreal. I sometimes see people calling blueprints no code. It's not no code. That would be like, I don't know. I feel like it's a misleading advertisement to call it no code. It's just like code in a different form. It's not like a Wix editor. You still have functions and macros and variables, and you're looping through things, and you're storing pointers to objects and maintaining how different objects communicate with one another. You're just doing it in a different format with a little bit or less control than you would normally have. But like I don't want to say that as a scary thing. It is a good thing, honestly, that is like a code in a different form, because it makes it a really, really great stepping stone into doing C++ in Unreal. I think even people who have a like normal, we'll say vanilla outside Unreal C++ background, jumping into C++ in Unreal is really, really weird, because there's so much of, I'll say, Unreal nonsense that the engine throws on top of it that makes just looking at a regular header file really weird. But if you're familiar with blueprints first, and just how Unreal works in general and how it wants you to set systems up, translating that into C++ is like an easier, I guess, an easier stepping stone to do that. So it's nice that it is not no code. For the folks coming from other engines, whether that be Godot or Unity or something else, some things in Unreal may seem a little bit weird. At least like the common complaints that I get with it is for Unity devs in particular, it feels like it's forcing you to build things with a lot of existing building blocks. And really that just comes with the engine itself has a lot of things available outside of the box, like you'll feel like you're restricted to certain nodes or certain opponents or certain types of actors. But in reality, most of this is available there for your convenience. Like in this workshop, because we're going to try to, we don't have much time, honestly, we'll be using a lot of the built-in stuff. But if you're a Unity dev thinking about like, oh, that's the only way you can make stuff in Unreal, no, it's not. If you want to, you can always make your own components, make your own nodes, make your own actors. And if like you ever want to switch between like stuff that's already exposed to blueprints and you're exposing your own stuff to blueprints or going back and forth from code to blueprints, you can do that. So yeah, you don't have to use a template project. You don't have to use like the projectile component or the character movement component specifically. You can, most of the time, usually use your own stuff when it calls for it. I will say the exception to that in particular is there are some systems that are quite complex where if you don't do it the Unreal way, you'll be fighting against the engine and it requires a lot of work. I'd say the general rule of thumb is if you're making something that's simpler than the way Unreal does it, like your character movement is a lot simpler than what the character movement component does, you can just do that yourself, handle input yourself, handle whatever you want yourself. Say you're like, this is a very tight-knit fighting game you're making or something. But if you're doing something that's more complex, or you're just trying to make slight alterations to how Unreal does something, then that like you might not want to do that. Then you end up fighting against the engine. But yeah, just kind of a note to keep in mind. Also, if you're used to working in Unity or something else, move the files inside the content browser, not in the file explorer. The assets are not just like the 3D models floating around. We're going to have things referencing each other, and it's going to create a mess. And when things are acting up, delete intermediate and saved. That's I think the best note I can give there, switching from one engine to another. Okay, so when it comes to blueprints, I think a really, really common question is, what do you do in blueprints and what do you do in C++, and how do those two interact with one another? Pretty much every project is going to use a combination of the two. At the end of the day, every blueprint class is going to inherit from a C++ class, whether that's you're just straight up inheriting from one of the like built-in ones in the engine, like you're just inheriting from actor or pawn or character, or you like have your own C++ class in between that and your blueprint class. Like that's up to you. But at the end of the day, you're just going to have like some sort of hierarchy where it eventually goes back to C++. You can also go in and out of blueprints in between C++, between creating functions that are blueprints exposed and creating blueprint function libraries. If anyone has like questions about those in particular, I can like give some more detail on that like towards the end of the workshop or during the break or something. But most of the time, just in an Unreal project, you'll be using both. So yeah, I'm going to go ahead and jump into the project here in a second. You will notice that within the content folder, there is a answer key folder that has pretty much all of the blueprints we're going to make today. And what I would really encourage you to do is to, if you get stuck, try to work through it first. If you're like really, really stuck and you're not sure, then look at the blueprints and the answer key, but ideally, don't copy and paste from them. Actually try to go and retype each of those nodes yourself. And the reason for that is because sometimes it could just be a matter of like you missed a small button or a checkbox up somewhere. And if you copy and paste it, then you're not going to be ever sure what was wrong in the first place. And you're likely to run into the same problem again later down the road when there's no actual answer key. So if everyone could, like, I don't know, swear an oath not to copy and paste from the answer key, that would be great. And then lastly, like I know everyone has their mic muted right now, because there is, like, we're going to get to like some pretty detailed instructions here. I'm going to ask you like, okay, check this box, plug this in here from this drop down, type in this thing in particular. There's a lot of points where you can make a very small typo or something, and then your blueprint doesn't work at all. So for that, I'd say if you're stuck, like I don't want to head on like that, continue down the workshop without you, just please let me know. Like feel free to unmute for a second and say like, hey, I'm just like stuck with this. If it's like something we're just heading too quickly, or raise your hand, and then I have like the chat over here on my laptop and I can make sure to check on it. I just don't want to, I want to make sure you all like don't get left behind. If it's a bigger problem, then we'll wait until like the break and kind of come back to it then. But for the small problems, I want to make sure you all feel free to like mention them on the spot. All right, cool. Blueprint time with Manny and Quinn, which for those of you who don't know, that's the name of the mannequins, the default mannequins in Unreal. All right, let's go out of Google Meet. Okay, so sorry about this. I was doing a test run with someone right before this workshop. If you all could go to the workshop folder and open up the level for the obstacle course, we can go into here. Sorry, I have a few things in there from the test run earlier today. Let me just delete that out of here. Okay, so what we have right now, what we're starting with, is for the most part a third-person template with a few things modified in it in a default level, where we kind of have, I don't think I can I make that jump? Yeah, I can. A few different platforms, Manny running around, and some sort of volume where if you fall into it, you go back to the start. And what we're going to try to do is we're going to make some obstacles to help and, I don't know, deter Manny from being able to get to the end up here. So, all right, to get started, let's go ahead and create our first blueprint. I'm going to go to my content folder and I'm going to create a new folder, and we're going to call this blueprints. Just so it's easy to see, I'm going to go ahead and set the color of it. But that's just me. You guys can do what you want there. There we go. We'll make it purple. Okay. All right. So once you've done that, I think the first blueprint we're going to try to make here is the spinning trap blueprint. This one's going to be fairly straightforward. So you're going to right-click in the content browser. You're going to go to Blueprint Class to create a new Blueprint class. And in here, we're going to pick the parent class to just be a regular actor. That's all we need. And I'm going to name it VP Spinning Trap. I'm gonna give mine an O2 just because I think I already have one in the project. But name your VP Spinning Trap. And I will open this up. Just double click on it and we can go to the blueprint editor, which I am going to dock up here because I prefer to have it on the same window as everything else. Now, depending on your background in Unreal, you may be familiar with this, you may not be, but when you place like pretty much anything in the world, whether that's a light or a static mesh or, I don't know, a height fog actor, the actor is the actual object that's getting placed in the world that like has this transformation. Most things are going to be, most things you're placing in the viewport are going to be actors. But if you click on any one of these actors, you can go to the details panel here on the right, and you'll notice there's kind of like a list of things over here. So if I click on this static mesh, here we have, within the static mesh, we have the static mesh component. If I click on the directional light inside of that, we have a directional light component. Inside the player start, oops, that was too fast. Inside the player start, we have like, it's the actor itself, but then we have a capsule component to define like where an okay starting point is and how much space you need for that. So pretty much, like, I think one concept that's like really, really important before we start making blueprints, especially if we're just talking about actor blueprints, is the actor itself may contain some logic, but it doesn't contain like your actual meshes and lights and stuff. Those are going to be in the components. So if, for example, I take this static mesh actor, I can actually add more components inside of it. Like I can put a cube inside of this actor and it's still part of the same actor. It's not like a different static mesh actor for a cube. It's just sitting right there. And very, very importantly, the transform for this object is not the same as like this object. You notice, like if I click on the actor, the location is going to be 610, 120, 400, right? It's not at the world origin. But if I click on the cube does in fact have a location of 0, 0, 0. And like for everyone who has a 3D background, like this makes sense to you, right? Things are parented in a hierarchy, but we'll be doing a lot more with like the actual mathematics of it in blueprints, where we have to kind of keep in mind that we have a actor that is in world space, and then each of the components, their transform is going to be relative to their parent. So our static mesh components, our cube here can have an offset of like -100. Oh no. Let me just type in -100 and the X direction. And it's not -100 from the world origin, it's -100 from its parent. And likewise, anything with the scale of our parent cube here is going to also affect its child, because it's transforming the coordinate space of that child. So, all right. I promise this is relevant for later. It feels like random information for right now, I'm sure. Let me undo all of that and put our platform back where it goes. Wow, I clicked on quite a few things, didn't I? Okay, there we go. That's fixed. So coming to our spinning trap. If I were just to like, so this button up here lets you browse back to where that blueprint is in your content browser. If I click this and I go to my spinning trap and I just drag it into the world, it has nothing in it at the moment. It's an actor, but it just has the default scene root. So in my blueprint editor, when I go back to that tab, what I need to do is I need to actually add the mesh that I want my spinning trap to be. So I'm going to go, if you're in your blueprint editor, the first thing you'll see in the top left corner here is this components tab. And you have this add button right here where you can start adding in whatever components. This can be components that are purely meant for like adding functionality, like AI perception or playing certain audio, or a spring arm or a camera or something. I guess those are kind of meshes too. Or it can be a mesh. In this case, I'm going to put a cylinder in here. If you guys want your spinning trap to be a different shape, feel free to add something else. And then with the cylinder, I'm going to make sure I have this selected, and I'm going to transform it into kind of a long horizontal cylinder. The keyboard shortcuts I used just there, Unreal uses Maya keyboard shortcuts, I think. I haven't used Maya in a long time, but it's W, E, and R. So W for move, E for rotate, R for scale. So I have the cylinder selected, and I'm just going to rotate that 90 degrees to make it like a nice piece we can swing around as a trap, and then maybe scale it a little bit to make it longer. The other thing I'm going to do is I'm going to move it so that one of the ends is aligned with the origin rather than it being like straight in the middle, and that'll help us when we're making it spin later. So when we spin it from the origin, it spins around rather than spinning around itself. Okay, cool. I'm just gonna give everyone a few seconds to get to that point. If you're good with that, let me know. Just like message it in the chat. Cool, cool. Alrighty, most people. Okay, so I'll go back to my level real quick, and you already noticed because I had put a instance of this actor in the world. When I add my static mesh component, it gets added to that too. I actually think I made this trap way too big. Let me make that a little bit smaller. Once I looked at it at the scale of the world, that's a bit much, isn't it? Okay. I'll compile and save that. That's good normal. Okay, I didn't even mention compile and save ones. So anytime you make a change to a blueprint, you got two buttons up here that are kind of pretty key. One is to actually compile the blueprint, and then the other is to save it. I think I'm like almost by habit continuously clicking these two buttons lately. If you ever get a really, really big graph, it can be a bit slow, but for the most part, it's usually kind of instant. Okay, so now that we've added a mesh here in our spinning trap, let's get into the actual logic portion of this blueprint. So we talked about the components tab over here. We've got the details of each, like the selected component or the selected blueprint we have. But then we also have these two tabs right here. You have your construction script and you have your event graph. The one we're going to look at for right now is going to be the event graph. So if everyone can switch to that. This is where we're going to start adding like the actual logic to our blueprint, or actual nodes. You have a few different events by default. I feel like the habit of most people who work in blueprints is to delete these all promptly to just grab the same things again. It's very similar to like the, why is this not deleting? Since 5.6, I've been having this issue where occasionally I have to reopen a blueprint and it's not letting me delete nodes in it. Yeah, there we go. I don't know why. I feel like most people's habit is just immediately go ahead and delete those all like they do the default Blender cube, only to go and type the same event in again. So what you're going to do is you're going to right-click on here, and when you want to add an event or node or access a variable or something, you're going to right-click and you get this really, really big search box, which you're going to type in the node that you want. In this case, I'm just going to do begin play, so I'll grab that same event. So you have that there, you click it, and you can click in it and drag it to move it around. And if you want to navigate around the editor, you can right-click and hold and drag. So just like that. Now, event begin play is an event that anything we attach to it is going to fire as soon as this actor is like has finished being created and is running in the game. I know it's the begin play. It's not when the game starts. It's when things start for the actor, I guess. So what I'm going to do is I'm going to go ahead and attach something to its execution pen here. And this pen and the wire coming out of it, it's essentially the same as if you were writing physical code, like what order the lines go in. It's the way to explain it's used to tell us like what nodes are executed in what order. So I'm going to drag off of it, and that'll give me a new prompt here. And I'm going to type in print string. We'll go find it right here, click on that, and then we'll do the most generic thing you could possibly do, and we'll type hello world in a print string. No one has ever thought of that one. So once you've done that, and you've added in print string on begin play, you can compile, you can save it, and if we go back to the obstacle course, as long as we have this actor in the world, when we click play, you should have hello world appear in this top corner for 2 seconds. Did everyone get to that point? Just double check in. Okay, cool. That was a very quick response. So, okay, that's kind of like the most basic thing we do is we could just go ahead and print a string. If we wanted to, and it's probably not too relevant for here, but it's going to be relevant for the blueprints we're going to create after this, so I'll go ahead and show it. But we can, instead of just having print string directly typed in here, we can store it in a variable, but that we can change from the editor. So what I'm going to do is over on the left panel here, you'll see the variables tab. And I'm going to click this new button, like this, sorry, not new, plus button. And that's going to give us a new variable. So I'll click plus here. Its name is going to be new var by default. I'm going to name it debug message because it's what we're going to print in our print string. And I need to switch the type if I click this drop down right here from Boolean to string. And now this, by default, like you can't really do anything this, like I can click this variable, and if I go to the details, you'll see a little note for default value that says, please compile the blueprint. Whenever you create a new variable, you're going to have to compile the blueprint again. So you just click that button up here. But now I can type in a debug message, and I'm going to default it to my new message, exclamation point. Okay. And so now I have this string stored in this variable for a debug message. I can take my variable, drag it into the event graph. I'm going to left click, and I'm going to get 2 options here to either get the debug message or set the debug message. For now, I'm just going to get it. Getting being like, let's get the value that's in it. In this case, the value is the string, my new message. Not setting it, that would be like if we wanted to change what's stored in here. So I'm going to get the debug message, and I'm going to plug it in to replace hello world. It was a bit short last time, so I'm actually going to expand this node, and I'm going to increase the duration here to like 5 seconds. We'll compile and save that, go back to level, play it again, and now we have my new message stored as a variable up there. Cool. Of course, even though this is print string, strings are not the only types of variables we're going to have as we like creating these traps. So I'm going to go ahead and create a few more, and we'll go through kind of like the commonly used ones that you'll be running into later in this workshop before we get to the point where we're actually needing them. So I'm going to create one that's like my int. And we'll switch this to an integer just being essentially a number that is like a number you would count. It has no decimal place value. So if I compile this, I can set the integer instead of 0, I don't know, set it to be 42 or 12. We also have a different type of numerical data, type in my floats, and get a floating point value, which instead of just being a number like 10 or 12, it's going to have a decimal place. So we can type in 12.777, something like that. And I know this probably seems a little boring right now. You're thinking like, okay, why is this relevant? Why do we need to have like one type of number to store numbers without decimal places and one type of number to store a number with decimal places? It will be important very soon. Just give me a few minutes here. Another type we're going to see is going to be a vector. So that's going to be the yellow one here. And I'm going to right-click and rename this. I'll name it my vector. And compile and save that. And we can give that some default values like, I don't know, 10, 12.5, -7 or something. There we go. And that is going to be used to store things like your position or your scale or a direction in space, stuff like that. And then the other one that we're going to be dealing with in this workshop is actually going to be actor references. So rather than just like a certain variable, we're going to be like referencing like an actual actor in the world. So I'll type in my actor. And to get this one, I'm going to, it's easiest to just type in the word actor, actually. I'm going to type in actor, and you're going to see object types down here. We're going to go hover over actor, and then right beside it, you're going to see a few options. For now, the only one you have to worry about is object reference. We don't need like a soft object reference or stuff. That's more for like loading assets. So we'll go to object reference, and we should have a light blue dot here that says actor. And this one I'll come back into a second. So now that I have these, just want to make sure we all are able to get variables and set them in editor. So I'm going to duplicate my print string node a few times. How many variables do we have for it first? Okay. And I'm going to take each of these, just drag them out, and click Git. And we'll come back to the actor one. And then we're going to drag them into print string. Now, obviously, this, as you may have noticed at this point, all of the different data types that we have, all these different types of variables, are in fact color-coded. So like the hot pink is going to be a string, the integer is going to be kind of a teal, the floats are going to be a lime green, vectors a yellow, and so on. And that is going to be really, really useful in working in blueprints, because if you're ever dragging something to one color pen to another color pen and it's not matching up and you're not sure why you can't plug it in, chances are it's just a different type of data, and you can't treat, I don't know, you can't treat a string like it's a vector by default. You'll notice with some of the types, just like we had with integers just now, Unreal kind of does an automatic conversion. So like I hovered my int over in string, and even though an integer is not a string, we get this little box that pops up, and it says convert integer to string, and then I hover over it. And if I click that, it gives me like this little conversion node where it's an easy conversion. It's not one we have to like really worry about the specifics of. So I'm going to do the same thing here for float, and the same thing here for vector. Okay. So once everybody gets to the point where you have a setup with 4 print strings and 4 variables of different types, let me know in the chat. We'll continue on. Tim is always the fastest. Okay, cool. So now if I go back to our obstacle course, and we go and click play again, we won't have just one message, but a lot of different things printed. My new message, my integer, my floats, and my vector. That was very quick, but you can see it up here in the top corner. Okay, so I'm going to stop that. So the last one here is going to be our actor reference. So it's important that when we talk about like an actor being stored as a variable, we're not talking about like the base class, like the blueprint class. We're talking about the actual instance of that actor in the world. So, okay. So if I were to do, let's see, we'll do get my actor. well, actually, I guess we first we'll do set my actor. So instead of clicking get dragging in, we'll do set my actor. And what we're going to do is we're going to get a reference to self. So if you right click and type in get self, you should see this node called get a reference to self. And what I'm going to do is I'm going to plug that in and set that to my actor. So now my actor is equal to this actor, whatever instance of this blueprint class is in the world. And I'm going to add another print string, just like the other ones. I'll copy and paste this one, actually. And if you put, it's kind of where the automatic conversion from actor to string is a get display name. So we're getting the display name of that act in the world. And to make this clear, I'm going to switch this duration to 10 seconds. Now, the important thing to note here is that if I now go to click play, actually I'll make this one orange so it stands out. If I go to click play, we have BP spinning trap 02 printed, right? Which is the name of our class. But if for some reason I had multiple BP spinning traps, so I'm going to copy and paste this a few times. And we click play again. Now I'll see BP spinning trap 02, BP spinning trap 3, 4, and 5. Because the actor, again, it's not this class BP spinning trap. It is the actual actor sitting in the world here. So we have here in our outliner, we have 02, 3, 4, and 5. Which will come to play later on, because I find a lot of people run into when they're first working in blueprints, they're like, okay, I'm just trying to get my character, or I'm just trying to get this one actor, and there's only one actor of it in the world. Surely if I'm like setting up some sort of logic in another class about that actor, the game knows which actor it is. And the answer is no. Even if there's only one in the world, it's still like an instance of it, and there's no guarantee there's going to be just that one instance. So this refers to like the specific thing you place in the world, regardless of how many there are. Okay, so that kind of covers the basic data types we'll be dealing with, at least today. Objects, vectors, float values, integers, strings. I forgot booleans. So if I just make a new variable here, name it my bool, we're going to have the first option here is a boolean. And that one is just going to be, rather than like a number or like some text or something, it's going to be a true or false value. You'll notice that here are the defaults. If you check this off and uncheck it on, it's just a checkbox. It's just true or false, that's it. And we'll use this for things like essentially asking questions about the state of a blueprint. Okay, is this far away from this, true or false, you know? We'll get into that later. So, okay, we don't need any of this. If you wanted to just leave it there for reference or something to come back to it later, and let's just slide it up here. But what we actually want to do is we want to go ahead and, you know, use a variable to spin our spinning trap. Now, you can define this functionality in the event graph, like set up the logic yourself, but there is a component that like gives us ready-made continuously rotating objects. So we're going to use that one. I'm going to go here, add a component, and we'll call it, add a component, type in rotating movements, and click on this one right here. And what this will do is actually, I can go ahead and compile and save this and go back to the level, and you'll notice happen pretty instantly. All of our spinning traps do, in fact, now spin and will throw me off the side of the map. Might be a bit short for it, but it did hit me that one time. So the rotating movement component has that logic in there, but if we want to control the speed of it, or like the rotation rate, you can click on the rotating movement component, and over here in the component, you're going to have the rotation rate right here. Now, you can just set it directly, but if you want it to expose it to the editor so that one spinning trap can go one speed and one spinning trap can go another speed, and so on, what you're going to want to do is you're going to want to store that as a variable. So I'm going to create a new variable. I'm going to name it rotation rate. And I'm going to switch this, because we actually didn't cover this type, but I think you'll get the hang of it, to a rotator. Well, actually, you know what? On second thought, we can do this with just a float because we're only assuming it's only spinning one direction. We're going to make the rotation rate a float. I'm going to compile it so I can give it a default value, and I'm going to make it 200. Now, if I go to the event graph on begin play, I'm going to grab my rotating movement, so I can just drag that off of here. By default in Blueprints, you can pretty much always access the components that are within the actor of the class that you're editing. So at any point, I can grab the default scene root of this, or the current cylinder, or the rotating movement. Just grab a reference to that. I'm going to grab the rotating movement though, and what I want to set is this rotation rate. So I'm going to drag off of this node, type in set rotation rate, and we're going to get this node here. Now, I don't want the rotation rate to be 0, 0, 0. I want it to be this rotation rate. So what I'm going to do is, since we're only rotating in the along the z-axis, I'm going to right-click on this pin, and I'm going to click split it. And this will essentially just take the rotation, which is in a way kind of a vector with some extra bells and whistles, and it's going to split it into 3 float values. And now I can take the rotation rate I defined here, get it, and plug it into rotation rate. Now on begin play, whatever rotation rate I've defined in my variable is going to be how fast it spins. So that should be 200. Is that really 200? That seems a bit fast. I'm going to shorten this again. Okay, sorry about that. Okay, so now these are all spinning at the same rate. If I wanted to make these spin at different rates, something we haven't done yet, but is going to be really important here, is to be able to expose this variable to be editable on each instance of it. So rather than just defining the rotation rate in here, we want to define the rotation rate for this, the rotation rate for this, the rotation rate for this, and so on. So I'm going to go here, and in my event graph, sorry, not in my event graph, I'm going to click on rotation rate, and I have 2 checkboxes I'm going to check. We're going to go over to the details and select instance editable and expose on spawn. And if we have those 2 checked, when I go and compile and save this, and I go to back to my obstacle course, now if I click on any one of these actors, I will see in my details over here that rotation rate is exposed. They're all 200 by default, but I can make this one 100, and this one, I don't know, 500, and this one negative 400 to have it go the other direction, or let's say 300 here. Negative 300. Okay. And so if I click play, we'll now have them all spinning at different speeds. It's a little chaotic at the moment. All spinning at different speeds and in different directions. So cool. How do you change the pivot? So the pivot with the actor, if we're using this rotating movement component, it's just going to be the center of the actor. So if we want to change where it's rotating from, then we have to move the mesh on, move how the mesh is oriented within the blueprint itself. So like if I wanted it to be kind of in the center instead, then I can set the location to be 0. And now when I click play, they'll all rotate from their center instead. So yeah, continuously rotating stuff. I'm going to very quickly maybe make these a little bit bigger. And I'm going to switch the material on my cylinder within the blueprint to be an emissive material so we can see it a bit more easily. If you guys type an emissive, there should be a, where is it? Oh yeah, there you go. MI blockout green emissive _00. What a naming convention. Click on that one. And when you go back to the editor, you should have your rotating traps flowing. So I'm going to save that again. And now let's kind of move these to a place where it makes sense for these traps to be. And you know what? Maybe I've made them too small again because they're never going to hit the player here. Let me scale that back up a little bit. Okay. Let's see. Could you repeat what you did before plugging the rotation rate to the set node? Yeah. Oh yeah. So for that, that's the split destruct. So if I right click on here, I can click recombine. If I right click on it again, you can click split. And that's just like the rotator, and just like a vector. I could do that to my vector as well. I can split it anytime. It's just made of multiple floating point values. So if I ever want to just edit one of them, I can always split that apart or recombine it together. How do you remove connection? I didn't, how did I? So to unplug something, you're going to hold down Alt and you're going to left click, and that will unplug a pin. Let's see. And then let's see, what kind of set node is that? So that is setting something on the rotating movement component. If you type in just set over here, you won't see it normally because blueprints are in fact context sensitive, like they care about what you have selected. But if you drag off of the rotating movement component, like you've dragged this in here and you've dragged off the rotating movement component, then you can type in set rotation rate. And then under variables, you'll see rotating component. And then within that rotating component, you have a rotation rate. That is actually something very, very important to note. Blueprints is all the time, for the most part, unless you want to check that box, and then it's kind of a pain to search through things, context dependent. So if I want options that are specific to my specific components, like say I have my cylinder and I want to set the material in it, like that is something that's going to be relative to something with mesh on it. Like I couldn't take my rotating movement component and type in set material. Like that's not going to give me anything. So when you're adding nodes, it's important like which I guess object you have selected that you're dragging off of. Unless of course you uncheck this context sensitive box, but then you will get a very, very big list and it's a lot to sort through where like certain things might have very similar names. Okay. Let's see. All right. So is everybody good to go on to the next track? We'll get into the trampolines. Okay, cool. Got one trap done. All right. So next one we're going to do, same as before, in our content browser, we're going to right click, go to Blueprint class, click actor just like before. And this one I'm going to call BP Trampoline. I hope I spelled that right. BP Trampoline. I'm going to name mine O2 just because I did a test run before this project. Before this workshop. So once you have that, you can open up that blueprint just like the other one. I'm going to dock it up here. And now we can start building our trampoline. The first thing I'm going to add in here is going to be just like the actual mesh to represent this is the trampoline. So for that, I'm going to be a bit lazy. I don't have an actual trampoline mesh, so we're just gonna use a cube. So I'm going to go to my components, click add a cube, and let's scale it down to be about the size of a platform of some sort. So I'm going to make mine, I don't know, 8 by 5 by 0.2. This is a 1 meter cube, so when I scale it, that's going to be like 8 meters by 5 meters by 0.2. Maybe we'll even make it 0.15 high. And just like the spinning trap, I'm going to give it a color. Let's type in emissive here, and I'm going to give it that same in my blockout green emissive _00. So we'll have it glowing. If you've got that, I'm going to compile and save. And inside our level, I'm going to drag in our, oh, man, that's kind of a big trampoline, isn't it? 8 meters by 5 meters is excessive. Let me scale that down a little bit. We'll do 6 by 4.5. How about that? Okay, that's a bit better. So everyone, okay, go ahead and add a static mesh in, assign a material. It doesn't have to be that material, whatever one you want to, and go ahead and like place some trampolines in your world. All right. Let's give it a second. Okay. So what I want to happen with this trampoline is I want to make it so that when the player runs onto the trampoline, they get thrown into the air. I don't want it to be actually on the box itself, because there's a chance they like are standing right here and they have 1 foot here and 1 foot here, and it'd be a bit weird if the trampoline threw them up just for like standing on the very edge of that. So instead of using anything with the collision of like this mesh itself, I'm instead going to add another component. So we're going to go to add, and I'm going to type in box. And what we want is just the box collision right here. So if you click on that box collision, you'll get what is a very teeny box right now. But if you scale it up, you can make it just slightly larger than the, slightly smaller than the trampoline. So when we're looking for a collision with the player, we're like not all the way at the end of that. And we just give it a little bit of a buffer room so they're not accidentally stepping onto it. Well, I think I'll do something like about right there. And you want to make sure the height extends a little bit above the mesh, but not too far. 1.4. I guess 1.4, 1.44 is what ended up working here for me. Okay, compile and save that. And now we're going to have cube mesh, and we're going to have our box. So when it comes to collisions in Unreal, there are a lot of settings between the meshes and stuff, with like how things query for other objects in space, or how they collide with other objects in space, and what affects physics and what doesn't. It does get quite complex, but for now, I think like we can try to keep it simple. So what I want to point out, the important section here, is under collision, you'll see these collision presets, right? And it's right now it's overlap all dynamic, which works for us. But there are different like collision presets for like how a pawn is likely to collide with something, or if you want to block everything and not allow it to overlap. In this case, we want our box to in fact overlap with everything. So I'm going to leave it as overlap all dynamic. But if we wanted to, like say that we only want the trampoline to throw the player in the air, so I'm going to set it to custom, and our player is a type of pawn. It didn't go through that hierarchy, but a pawn is essentially the parent class of a character. Like all characters are going to be pawns. We could say like, okay, overlap with pawns, but like ignore vehicles, because vehicles can't go on the trampoline. They are not allowed. Or physics bodies or destructibles are not allowed on the trampoline. We don't count them. We can ignore that. But for now, I'm going to keep it simple, just so you know that's there. We'll get to it later. And I'm going to set it back from custom to be overlap all dynamic. Okay, so once you have that, we talked a little bit about like begin play and the event graph, but the one we're going to want to look at now is not like an event that's relative to the whole actor. It's an event that we get just on this box component. If you click on it again and you scroll down to the very bottom here, you'll notice a bunch of events that you have like available to you to use. So like you use on component hit, or on clicked, or on input touch, or stuff with the physics volume. Most of these I rarely ever use, honestly. The most common two are probably on component begin overlap and on component end overlap, that like behave pretty consistently. So for on component begin overlap, that's when we say, okay, something in the world is overlapping our box. We want to check, is that the player? And if so, let's throw them into the air. So I'm going to click this plus button here, which would decide on component begin overlap. And I'll go ahead and delete these other ones. And now what we can do is now when something overlaps this box, we're going to get information about the thing that overlaps the box coming in with this event. Just to show what that does, for now, I'm just going to do a print string. And we're going to print the actor that was overlapped. And I'm going to make it a bit longer so it's easier to see. I'll print it for like 5 seconds and I'll make it orange. I'll compile and save that. Go back to the level. And now you can tell if when I walk onto this, you're seeing BP third person character 0 print in the top left corner. It knows that the character has overlap with it. Yeah, and it's going to fire every single time the character enters it. So you'll notice it's not when the character is continuously standing on it, not when they're leaving it, only when they first enter it into that invisible box. Okay. So in here, now that we have that, cool. Okay, we have a reference to our actor which is overlapping. Now what we want to do is actually throw that player into the air. So the node we're going to use for that, let me delete these, is called launch character. You will not see it by default because I don't have a character like selected. Again, Blueprints is context sensitive. But if you uncheck context sensitive, you will see it right here, launch character. So what's going to happen then is if I say, okay, the other actor that we're overlapping with, let's launch the character. That's not going to work. Like this will not let you plug it up because even though these like are both blue dots, they're like technically different types of data. So the actor here, we hover over it, it'll say it's an actor object reference. And this target here, if we hover over it, it's a character object reference. And this is where we're going to need to do something called casting, which for those of you like some programming background, you may be familiar with, but for everyone else, I think this is kind of like a weird thing conceptually to get your head around. Let's see. Let me double check. Sorry. How to find launch character. Yeah, so right click, make sure you have context sensitive unchecked, like you want the big full list, and type in launch character. And that'll give you this node. Cool. And so I'm saying I'm also getting the spinning cylinder names along with the character actor. Spinning cylinder names. Is it possible that the print string is still plugged in on your begin play? Right, names. If that's not what you're talking about, we can come back to that during the break, and I will help you fix the spinning trap there. But okay, gonna move on with the trampoline for now. So the on begin overlap, we're gonna look at trying to cast to make this like the right type of data. So I'm gonna open up Photoshop real quick. This is gonna be my blackboard, or whiteboard. I don't know. It's closer to a blackboard, isn't it? And what casting is, and I think the easiest way to think of this is going to be asking, why do I have the vertical type? I do not want. No, I don't. Okay. Casting equals, are you a blank? Like, if you're casting something, you're asking it, are you a specific thing, kind of. So if we look at the hierarchy of like types of actors going down to a character, we have a regular actor, right? And a subtype of actor is going to be a pawn. And a subtype of pawn is going to be a character. So if I were to draw like a tree, why is the default line green? Why did I do that? So a pawn is a type of actor, a character is a type of pawn. You also have other types of actors like our spinning trap or a static mesh actor. So like, say your spinning trap, we made that as a child of actor. It is also a type of actor, but it's not going to be a type of pawn or a type of character. So that's going to look like that. Now, on this overlap, we only have an actor reference. So we know we overlapped the thing we have, that blue dot, is this actor here. But we don't know whether that actor is a spinning trap, whether it's a pawn, or whether it's a character. So we want to ask it, hey, are you a character? Because this launch character node, target is character. It only works on characters. So what we need to do for that is casting, which is going to ask the actor, hey, are you a character? And then we're going to have our data, output the data in the form of a character. It's not, I feel like this is the, like on a technical level, it's not exactly like asking, are you a blank or something, because you have like casting in different directions and how compiles is different. But I think like from a conceptual standpoint, you can think of it as asking an object what it is, or if it is a thing. So I'm going to type in, I'm going to check off context sensitive again, and I'm going to drag off of other actor, and I'm going to cast to character. Right? So we'll click that. And now we have our cast node asking if this is a character. So what we have here is we have the other actor. We ask it, is it a character? If it's a character, we launch the character. If it's not, then it's going to execute this execution pin, and that means something else that is not a character overlapped it. Cool. So now that we have that, what I'd like to do is go ahead and actually launch the character into the air. Right now we have a launch velocity of nothing. Nothing is going to actually happen. So what I'd like to do is similar to our rotating component. I'm going to add a new variable. We'll call it launch velocity z. I'll make it of type float, not integer, 64, nope. I'll make it of type float. I'm going to compile it so we can give it a default value. I'm going to, what should we do? Let's say 2000. Is 2000 too much? 2000 is probably fine. Maybe we might have to edit that there. But I'm going to take the launch velocity z, get it, just like with the rotator before. Instead, we're going to split this vector right here, right click, split vector, and we're going to drag launch velocity into z. And I'm going to also check off this Z override. And what that's going to do, you can cover over it and it'll see the tooltip. But if our player is jumping, it's essentially going to override their upward velocity and just replace it with whatever we've defined. And if we check that off, that means our trampoline is going to have much more consistent behavior. So, okay, give that a second in case anyone missed anything. You're going to split that pin here, plug in launch velocity, give launch velocity a default value, make sure you're casting a character, and check off Z override. If you've got that, then you compile and save. And now we can test our trampoline. Now, if I walk into it, there we go. My character is getting thrown up into the air, immediately into the death zone, kind of. I might need to give it a little bit more velocity. Let me increase that here. I'll do like 2,400 or something. Maybe that'll be good. Let's try that again. Okay, one trampoline, two trampolines. Okay, I made it over to the spinning trap zone. Cool. Did everyone get to that point? And does everyone understand what happened there with the overlap event and cast into the character? Okay, cool. So, yay. You're like, I think it's maybe because everyone has like some backgrounds in 3D of this. I was test running this earlier. It's one who didn't have any background, like much background in Unreal or 3D stuff in general, and they were having so much trouble with like navigating the node graph. I was like constantly checking in, but so far everyone is saying like, "Yep, I'm good." You know. Yeah. How we set it up right now, it's quite literally on overlap. So it's not, trampoline doesn't only work when we jump on it, but it's going to be anytime we actually overlap with it. If you wanted to make it so it's only when you're jumping on it, I suppose you could check if the easiest way to be check if the character is actually in the air or is falling. If you want to do that, we can come back to it after we've gone through the other obstacles. But for now, it's kind of set up in a way of just, if you wanted to, you could run onto it instead of jumping onto it, and you would still get thrown up. Yeah. If yours is only working when you jump, I ran into this earlier. It may be that your collision box is a little bit too low, and it's affecting when you hit it. So I'd say increase the height of it a little bit so it extends a few, like 5 or 6 centimeters above the platform rather than like being exactly flush with it. And that might fix it. Okay, let's see. So now, okay, we've done like 2 graphs that are like 1 node or just 3 nodes. Now let's jump to a graph that like actually has some stuff going on in the node editor. And we'll also cover a little bit of graph organization. We are technically past the point in time I thought we'd be. So I'll try to speed it up here, but we'll do 1 more obstacle and then take the break. How about that? Okay, so next blueprint we're going to make is going to be a moving platform. I'd say the American term for it is like a moving sidewalk. Gosh, my spouse was telling me like the normal term for it here, but moving sidewalk, everyone knows what I mean. Okay, so I'm gonna make a new blueprint just like before. Again, we're gonna make this one an actor as well, and this one we're gonna name BP moving. I'll name it moving platform, and this one O2 as well. This one, we're going to kind of start the setup exactly like we did the trampoline, where we're going to add a cube, and then we're going to add a collision box. So I'll open that up, add a cube in to be our platform. I'll make it short, just like the other one, and then kind of fat. There we go. I do, for this one, have a material that you all can use. So if you go to materials, type in moving platform or just moving, and you should see this M moving platform right here. And then you get some procedurally generated triangles moving across your shape. So that'll make, hopefully when we add this in the level, make it look a little bit nicer, a little bit like we didn't just add a cube into the world. So I'm gonna put it on this for now, so it's easier for my character to reach when we're testing it, but we'll put it in the actual level in a second here. Okay, there is my moving platform. Just like the trampoline, we're also gonna add that same box component. So again, we'll go to it, add a box collision, and just like the last one, we're gonna make it a little bit smaller than the actual mesh itself. So yeah, something like that. I'll do 1.4, 1.3, I guess. And let me shorten that a bit. Okay. Travelator, yes, that's it. Thank you. Yeah, I was proud of my little translating triangle material here because it doesn't use any textures. It's just HLSL triangle. It's totally necessary. This is not a materials workshop, so we won't go into that. Maybe if anyone wants to look through it later. It's called Copying from Shader Toy. Pro strategy is copying from Shader Toy. This one, let me make an illustration because I'd like to do this in a little bit of a smarter way than like brute forcing it, and we can kind of introduce a few more things in blueprints here. So to get things to continuously move, what we're going to use is in fact this event tick, which we kind of ignored before. And event tick is tricky because unlike that overlap or the begin play or the construction script or like usually custom events you make, it's not going to be just like you fire once and forget it. Event tick is going to fire every single frame. If I'm running at 60 frames per second, then whatever logic I hook up to this execution pin is going to be running like 60 times every second. And that's a bit much. So what you'll see commonly done in blueprints, and you can even do it in the project settings, is by default. So I'm gonna click up here on the blueprint, and I'm gonna go up to a section here where it says actor tick, and you'll see start with tick enabled. Normally when working in blueprints, unless you actually need it, you go ahead and assume that you should be turning that off. Just for the sake of like optimization, because you don't want like tons and tons of blueprint logic on tick. But in this case, we do want it. So what we're going to do is we're going to set up a system where we control when we turn on tick and when we turn off tick. And let me draw a quick. What was I doing here? We'll draw a quick picture for that. So what I'd like to do is if we have our moving platform. This is our moving platform. It has a green arrow on it. Here's our, direction it's going. I'm drawing with a mouse. Like, this is my excuse here. I could sometimes draw straight lines in Photoshop. But in this, we, of course, have our little collision box. I'll make it kind of a gray box here. We have our little invisible collision box. And what we'd like to do is when an object, say that is the player, or a box they're carrying, or I don't know, a weapon they drop, when they step into the box, we'd like to make them start moving. And when they leave the box, we'd like to forget about them. And we like to keep track of the things that are on the box and not on the box. So say there's a character enters, there's, I don't know, another character like an NPC, and some sort of like physics objects, like maybe a cube or something that's rolling around the level. When these enter, we want to keep track of all the things. So we'll say like, okay, we have some sort of structure, or data structure, where we're going to store a reference to our player. We're going to store the player, the other character, and we're going to store the box. And on tick, we're going to update their positions. What we want to do though is when that like storage that we have is empty, we want to turn off tick. And when there's something in that storage or on the box, we want to make sure it is updating. So say a player enters the thing, we turn on tick. Another character enters the thing, we keep tick on. When the first player leaves, we keep tick on because there's still something standing on it. And when the last thing leaves and there's nothing else standing on the box, nothing else standing on the platform, we turn tick off. So on, off, turn tick off, but only when everything else leaves. And to do that, we have to track the things that are actively sitting on it. So I hope that makes sense. Hopefully make a little more sense in blueprints. If it doesn't, let's jump over to that. So what I'd like to do is we'll start with the box here. And in order to track what's coming into the box and what's leaving the box, we're going to use the onComponentBegin overlap, and then we'll click on it again, and we'll also use the onComponentEnd overlap. So something will fire when it enters and something will fire when it leaves. And what we need to do is we've already set tick disabled by default, but there is a node for set actor tick enabled. When something enters the box, we of course will want to set tick enabled, and we will also want to track the thing. There are a few different ways to track like a group of actors. An array is probably not the best way to do it, but it is like a very common data structure and more common like than others. So I'm going to use it for that. So what I'm going to do here is I'm going to create an array, a new variable. We'll call it actors to move. Right. And now I'm going to go over the details, and I'm going to switch it from a Boolean to be of type actor, just like we did before. We're going to hover over actor, and then we're going to click on object reference here. Make sure it's actor specifically, not like actor event or actor action utility. There's a lot of things with actor in the name. Just plain actor, and you're going to click object reference. Now, normally this variable is just like a single actor, but if we want to store a whole bunch of actors, then we are going to use an array, or like that is one of the things we can use. So I'm going to click this drop down and switch from single to array. Actors to move. And by default, this array is essentially like a big ordered list of different actors that we have. And right now it's sitting empty. When something enters the box, we want to add it to this array to attract it. So I'm going to drag off this actors to move. I'm going to use get actors to move. And then from that, I'm going to drag off a node and we're going to click add. We have two different adds. I'm going to use, I don't think there's a scenario where we could accidentally have the same actor added twice, but just in case, I'm going to use add unique. And we're going to drag off this add unique. So we're taking this array and we're adding some sort of element, and that is element that we're adding is going to be the other actor. Let me line that up there. Also, I just realized I just used rewrote nodes and didn't explain how I did that. If you ever have a wire crossing through things, you don't like how it looks and it's not very organized, you can double click on that wire and you get a rewrote node. And if you ever have two pins, whether it be, or two nodes, whatever it is, that are in a wiggly line and you don't want them to be in a wiggly line, there is an auto straighten keyboard shortcut. I have mine set to, let's see. So I have my keyboard shortcut set to H. I believe it is Q by default, I think. Oh, yeah, the default is Q. So if you select things you need to straighten and you click Q, you'll get it in a straight line. Okay. So cool. We are tracking that. For now, I am going to in fact cast a character here just to make sure that we're we have to deal less with like collision settings, and they will adapt this to do things other than just characters later. So let me add a cast a character node right here, and then we'll add that. Or technically, there is also a node which is more efficient than casting. If you ever need to check that an actor is a certain class, but you don't actually want to cast to it, which gets into various reasons for why you would not do that. That actually gets a bit further than I wanted to in this workshop. Then you can also use is a character, or even better yet is a soft reference. Okay, sorry, I'm realizing here I'm defaulting to how I would normally do things, and it actually introduces a lot of concepts we don't want to introduce yet. So you can do that if you're familiar with it and comfortable with it, but if not, we'll just leave it as a cast. Can I do a recap of what I did there? Add unique. Yeah, sure. So how our array is going to work is that's kind of like what I was representing with this little box here of things we're structuring. But really what it is it's a long, it's a long list of like different elements. So say we have an array that has 4 things in it. It starts, why did I count like that? Because I said 4, so I wrote 4. It has 4 things in it. It'll have them in a certain order, starting at index 0. So we have index 0 will maybe be one object, like object A. I'll just type in A. And something else is a character. I'll type in, write in character, char for short. And then, I don't know, we have another character B, and so on. What add unique is going to do, rather than just this regular add. So what add will do, is it'll say, okay, we have this array, we're adding another element to it. So if I have a character C, and I add it and assume something is index 3, then at index 4, we will now have character C. And that will be add. What add unique does though is it makes sure it doesn't exist already. It makes sure it doesn't exist in the array before it actually adds it. So if for some reason, like A is already in this array, it's at index 0, but I try to use a regular add node and I say add A. Well, if I use regular add A, it will in fact do it. Like it'll just say, okay, index 5 is also A. I know we already had A, but now we have A twice. And if you're iterating through that later, you can accidentally like do certain effects on A twice that you didn't mean to do. Add unique just says, do we have A in here already? Okay, only if we don't have it, then we should add it in. So yeah, it's it is not quite as efficient because again, you have to check if something exists in there already. So you have to look at the stuff and read through it, but it just prevents accidents like that. Does that make sense? Yep. Okay, cool. Okay, so we add unique, we add our actors to move, and we set tick enabled. Now on end overlap, we want to do the exact opposite. So we're going to do the same cast to character, which is, you can probably check just say is a character, but we'll keep this simple for now. And then when it leaves, we want to remove it from the actors to move. So I'm going to copy and paste that actors, and we're going to remove item, which is, you'll never guess, the exact opposite of add. So we take that and we do the exact opposite thing we did before. Instead of adding it, we now remove it. Oops. There we go. Now, we don't want to, like, we turned tick on when something entered it, but we don't necessarily want to turn tick off the moment we leave it. And that's because just because one thing left it doesn't mean everything left it. Like, you still want to move the actors that are still standing on the platform. So what we want to do before we turn this off is we want to check if actors to move is empty. Are there still any actors that are on the platform that we're tracking? So to do that, I'm going to take actors to move, I'm going to do a git, and I'm going to drag off of it and use the node is empty, or easier is not, sorry, inverted is not empty. No, if it is empty. So is it empty? That gives us a Boolean, a true or false value. Is actors to move empty? And from that, we can drag off of this, and we can use a node called a branch. Now, the thing with like, I guess a branch node, you'll see we kind of get like two different execution pins, one path of logic to follow if the thing was true, one path of logic to follow if the thing is false. And most programming languages would just be if. In fact, if you drag off a Boolean, if you type in if, you will get branch to show up. I don't know why they call it a branch in Unreal specifically, but that's what they call it. So if actors to move is empty, then we are going to set tick enabled to be false, and we'll turn that back off. So cool, we have, I'm going to drag around here, put a comment box. The keyboard shortcut for comment box is the letter C. So I can drag something, click C, and then type in. So I'm just gonna label these. I'll put in track actors on platform and track actors leaving platform. Okay, does everything there make sense so far? Okay, cool. So now we want to add in like the actual moving logic. And for this, what we're going to use is a node called add actor world offset. So if you just type that in, you'll make sure you're doing world offset. I believe there's a local offset as well. We don't want that one. We want the world one. Add actor world offset and add that on. Sorry, just having to change some things on my screen. Okay. So what we want to do is we want to add an offset in the direction of the forward direction of our platform. So if you go back to your viewport and you select the cube we have, and you go to like the regular move gizmo, you'll notice X pointing this way in the direction we're going, hopefully, and like Y off the side and Z straight up. We want to move the actor in the direction of that X that is local to this cube. Or like, sorry, yeah, the X direction of the cube, or AKA and unveil the forward direction. So what I'm going to do for that is I'm going to take the cube and grab a reference to that, and we're going to do a get forward vector. And that'll just get that forward a good X direction of our component. Then to make sure that the direction we're pushing the object is only in the X and Y direction and not necessarily like pushing it up or pushing it down, we'll just let gravity do that work. I'm actually going to do a second node here where we make a literal vector, not make literal, make vector. And I'm going to split this and plug in just the X and Y. Okay. So get forward vector, split it, make vector, plug in just the X and Y, leave the Z to be nothing. I'm then going to take the output vector and normalize it. Just because we had a vector of a length with 1 of get forward vector, we had like a unit vector direction, and then we kind of destroyed it by popping off one of the whole components. So we're going to normalize it again to make it equal to 1 again. Okay, and then I am going to multiply it. So let me add a comment here. So this is our move direction, and now we need to add move speed. So we have this tiny little unit vector where if I plug this straight into add actor world offset, that unit vector has a length of 1. Like we're in world position, we're only going to move the object on the thing 1 centimeter, which isn't necessarily what we want to do. So instead, what we're going to do is we're going to take this vector that indicates the direction we want to go, and we're going to scale it up to be a larger distance. But I'm going to switch this to a float real quick. And I'm going to make a new variable, and we'll call that platform speed. So I'll make platform speed. And this one, we can switch it back from array to single. We don't need this to be an array. We can switch it from actor to float. So we have a single float called platform speed. I'm going to compile mine and default mine to like 500. So we'll take platform speed, we'll multiply it by this tiny vector, and that will be the change in location. There is just one more problem with that. So if we plug this on event tick, like I mentioned, tick is firing every single frame. So if it's running at 60 frames per second, then we're going to call whatever is on it 60 times. But if it's running at like 10 frames per second, then this is only going to like call 10 times. And we don't want the speed of our moving sidewalk to be dependent on the frame rate. That'd be a bit silly, right? So that's why we have this node here for delta seconds to represent the actual change in time between each frame. And to use, to like kind of control the speed regardless of frame rate, what I'd like to do is take this platform speed, multiply it by this delta seconds. We'll reroute this down here. Get to that, and then actually plug it into the direction. So now we kind of have the speed controlled for the frame rate, multiply it by the move direction, and that's going to be the offset that we apply. Now, the last thing to plug in here is what we're actually applying this offset to. Well, we want to make sure we iterate through all of the actors that we have and apply the offset to all of them. So what we're going to do for that is a for each loop. So I'll type in for each, and you'll see under utilities array, you have this for each loop. We're going to click on that and plug it up to our event tick. And we're going to plug in our actors to move into the array. And what this is going to do is it's going to go through, you'll notice the array coming in and a single element coming out. It's going to fire this execution pin in here for every single element that is in our array. That means like if I compare it here, first time it executes, it's going to give us an index of 0 and an element of A. Next time, an index of 1, then the element is going to be the character, next time an index of 2, next time, and then the element of character B. And so with the for each loop, we can iterate through everything in an array, and we can apply like the same logic to each thing in it. So I'll plug that loop body up to add actor world offsets, and then plug the array elements into the actor target. Does all of that make sense? Okay, cool. All right, now if I compile and save this, I'm not 100% sure, but let me go check. We step on it, yep, and it starts moving us at a certain speed. There we go. And I guess you can't really see it, but when I leave this platform, our blueprint is going to turn tick off on itself. And when we enter it, it's going to turn tick back on. So I think, so that covers like the 3 of the more simple blueprints. I have 2 more kind of complex ones, but before we jump into that one, I want to make sure we can take a quick break here. And then for anyone who is stuck or having errors, we can sort through that. Since it is already looking at the time, would everyone be okay with doing a 15-minute break rather than like a 30-minute one? And we'll sort through any issues anyone has. You guys can screen share, and then we'll come back and try to look at the more advanced blueprint, see if we can fit that one in. Okay, cool. Sweet. So it is 38 past right now. Okay, maybe it would be 10. Because we are running out of time, I want to make sure we can get to the more advanced blueprint. Are you all right with doing like 12 minutes and we'll come back at exactly 50 past? Is that cool? Cool. All right. I will see you all at 50 past. If you're stuck and want help, feel free to unmute your mic and we can kind of, if you want to screen share, we can go through it. Turn my screen share off for a second here.
Hello.
Hello.
Hi. First of all, nice meeting you for the first time.
Yeah, it was weird bit to like say hi to people over chat. I wanted to do proper introductions, like then we like there's so much we need to get through in the time we have. So.
Yeah, no, that's not an issue. All right, so I'll quickly get to my problem. I don't know, I have not gotten any compilation errors or anything, but the platform thing is just not working. How do I?
Yeah, could you screen share what you have?
Yeah, just 1 second. Okay, I have this, and it's a mess, but this is what I've got so far. I am not sure what did I do wrong over here. Can we go through it
sure.
one by one?
Mm-hmm.
So one thing that I'm not 100% sure about is that what does this thing do? Like whenever any actor is interacting with a collision box, it just gets the information on what that actor is. Is that it?
Yeah, pretty much. So it's saying this is the thing that hit the box, or just entered the box.
Okay, so we
it's
just
other
take that.
actor because like this actor would be the moving platform itself. The other actor is the thing that's overlapped with it.
Okay, that's why it's another actor. Okay, got it. Anything wrong over here? Can you see?
So okay, actually, yeah. So there, the set actor tick enabled. When something enters it, you want the tick to turn on. Right now, the enabled checkbox is checked off.
Oh, okay.
Yeah, so that might be it actually, if you want to give it a go.
Okay.
So the first one should be turning on, and the second one should be turning off.
Okay, got it. Okay, so this is what happens when the actor leaves the box, and this is what happens when the actor is within the box. So it enables this, disables. Okay, got it. I'll give it a go.
Hey, there we go.
Okay, awesome. Thank you so much.
No problem. Yeah, like I said, with like running into issues with this, you miss one small checkbox and suddenly nothing's working.
That's exactly what I missed. How ironic.
All right. Okay. I have an error on actor and overlap. Yeah. Christine, do you want to go ahead and share your screen, we'll see what that is. Oh, wait, it should be on component end overlap if you're looking at the box specifically rather than the whole actor. Okay. Yeah, there we go. So you have a warning over that, and if you hover over the warning, it should tell you what the problem, or will show it in the thing. Does not have validating matching component. So the one you want to use, if you click on the box component and the viewports and the components, and you scroll down the list on the right, you should have a checkbox beside, so it's like all the way at the bottom down there. We'll do on component end overlap. So right beneath the begin overlap, you'll see one beneath that. Further down in events, very, very bottom. Yeah, that section. So at the top of the events list, there's the on component begin overlap, and right beneath it, the end overlap. So add that one, and then plug that one instead of the actor overlap. You should be good. And then so mentioned the blueprint runtime error of access none trying to get actor world offset. Okay, so with that one, there's something I didn't quite cover here. So we are doing something a little bit risky in this graph. We're iterating through these actors, and we're assuming that that actor still exists, and we can like add it. What you would normally do to just kind of play it safe is do a check called is valid, and that just makes sure the actor actually exists. Because what can happen here is anytime you see one of these like light blue dots, one of these, I guess, objects being stored as a variable in blueprints, it's not actually the whole object itself. It is the address of that object in your RAM, like actually. And the blueprints kind of abstracts this way from you and hides it a little bit. But what can happen is that objects, like the address of it in the RAM, can be totally empty. Like say, for example, this, say the player dies on the moving platform. If the player dies on the moving platform and then the player gets deleted, they never exited the platform. And it may try to run this, and it may try to add actor world offset and have that stored, but the player like doesn't exist for some reason, or say like it's marked to be like it's about to be deleted, then you could have like an object that is invalid. Well, it's not quite that. It's valid is different than checking if it's null. But I guess similar concept in mind. If you have something stored in a variable that doesn't actually exist anymore, you might need to do one of these checks first. Yeah, but if that's ending up there in the first place, that might mean that something else is wrong up here. So if you want to screen share that.
That actually fixed it.
Oh, okay. But it might indicate that there's something in there where it's like, because it's getting an invalid actor somehow, and it's not the player, so I don't know which one it is.
Gotcha. Let me pull it up.
So what I'm going to have you do is, do we have to? Okay, we have 4 minutes. Maybe we have to do this. I haven't actually like covered debugging in blueprints yet, but you can do that.
Okay.
So I'll show you how to do that real quick. So what we want to do is we want to stop stuff when it's getting added, or I guess stop it when we're iterating through this and see what it is that object is. So I'm going to type in this is valid that you have, so mine matches. And then I'm going to right click on this node and I'm going to click this add breakpoint. It will show you an exclamation point of like, hey, this isn't ready to go yet. You just have to compile and save it. And let's see, to do this, I'm going to split screen real quick. Do that. Okay. And so what it's going to do is it's going to freeze our code at the point where it's trying to iterate over that and move the actor. And then we can actually look at the value and see what actor it's trying to move. So I'll, step onto it. And there you go. I should hit that breakpoint. And now my game is frozen, my graph is frozen, and I can hover. Why is there no debug data here? Why does Blueprints always do this? Okay, I can hover over the array, and I can open up the array and see all of the things in it. So in this case, mine doesn't have anything invalid in it. The only thing in here is my BP third-person character, but you might have something else in that array if you try to do the same steps. So the little tiny blue dot right before add unique, just the rewrote node will show it for you.
Oh, okay.
BP third-person character. It is in fact BP third-person character. Okay, click continue. So on the top, you're gonna, instead of clicking play, sorry, or I guess you can click play. The breakpoint will get hit again. Zoom.
Yep.
All right, and that is the only thing that got added. So it didn't get hit again, which means nothing else got thrown in there. Okay, we might, since it's working for now, that is valid as catching whatever it is. It will technically work, but it means there's might be some junk in that array that doesn't need to be there. So we can take a look at it after the workshop, since you're right at 9:50 if you want to.
Sure. Yeah, that's cool. Thank you.
All right, I give everyone one more minute to get back, and I'll open up the next demo thing. We're doing this. I don't think we'll have time to get to all of the both the bouncy ball spawner and the player seeking bomb. The player seeking bomb is going to be a little bit trickier than the last graph. It's just definitely going to have a lot more nodes in it. So there might be a little bit, I'll try to comment it as much as I can, but and I'll try to fit it in the time we have, but we may not get through all of it. If we don't, then you guys can always find the rest of the blueprint and the answer key, and it's the exact same graph as what's in there. If everyone is back, I will go ahead and start sharing my screen again. I forgot to give speed to the platform speed. Yeah. Oh, with that one was, it was moving it. It was just having an error where it was trying to move an actor that doesn't exist. But I've made that same mistake earlier today with the platform speed. Okay. So yeah, thus everyone, there's your small taster of blueprint debugging. It works kind of similar to debugging in code, except you see a little bit less than you normally would. And if you ever have something that's going wrong, you can always add a breakpoint and then just have your code freeze at that point and then see what value is going in and what's coming out. That's not what it's supposed to be. Okay. Okay, now we'll get to the big blueprint, and we'll try to fit this in with the time we have left. I'm going to draw a picture before we do it because I want to make sure everyone knows what we're doing before we just start pasting things. So what I'm going to try to create here is essentially a bomb that follows the player, and when it gets to the player, it blows up. So it does a few things. We're going to have this scary looking cone guy. Sorry, I'm going to set my thing up so I can make sure I can see the chat as well. Sorry. Okay. There we go. We're going to have this is our bomb. We're following explosive. And it's going to, and here is our player. Now, our bomb is going to have some sort of radius around it, at which if the player walks into this radius, then it's going to start following them. So say this is I don't know, 2,000 centimeters away or something. We go to that, and if it's there, then it will start moving towards them. As it's chasing them, it's going to check two things. It's going to check, am I close enough to it? If it gets up to a certain distance, say 100 centimeters away, then the bomb is going to blow up. But if it gets too far away from the point that it was started at, and let me finish drawing him here. He's this is not the best illustration. Why did I do this? So if it's within a certain radius of the player, then it explodes. If it gets too far away, though, from its starting location, like this distance here, then it's going to turn around and go back to its starting position. So that is what we're going to try to make. So in order to do that, it needs to do a few things. We're going to need to track where the player is. That's going to be important. We're going to need to track where the starting position is to constantly check how far we've gotten away from it. And then we're going to need to change the object's movements based off of that. So, all right, this is going to be the biggest blueprint we've created so far. So I'm going to, same as before, we're going to start it as an actor blueprint. And I'm going to name this one BP player seeking bomb 02 because I have duplicates of everything. And we're going to open this up, and I will go ahead and add a very angry looking cone. Let me make him an emissive red. So there's the block out emissive green that we've been using, but there's also a block out red emissive that we can use. Then I'm going to compile that. I'm going to go ahead and place one in the level near where my player is starting. Or heck, we'll place 2 of them. All right. Now let's go ahead and add that trigger volume that we mentioned. For when the player walks into it, we want to say, okay, they're close enough for us to try to chase. So I'm going to go here, add a new component. Instead of a box this time, we're going to add a sphere collision. But works similar to the box. I can go to it, and I'm going to set a radius. Let's say it's like, I don't know, 10 meters on either side. So we'll make it 1,000. Oh, that's a bit big. Let's do like 500 or 600 as the radius. Okay. Now, if I go back to my level, I should have these guys with their volume. I'm going to move my player start. So my player start is starting outside of the aggro volume, just so we can test if it's actually working. And they're going to, let's just put them out in space here, actually. They can float. Okay. All right. So first thing we're going to do, I'm going to go to our event graph. Like I mentioned, when we start chasing the player, we're going to track how far have we gotten away from the point we started at. And to do that, we need to go ahead and on begin play, track where's the cone at the very beginning in order to see how far away it's gotten from that position. So to do that, I'm going to create a new variable. We're going to call this starting location. And we're going to make it of type vector. And right on begin play, we're not going to do too much. All we're going to do is take that starting location and set its value on begin play. Now what its value is going to be equal to is the location of our cone. So I'll take our cone, let's grab a reference from there, and we'll do get world location. Get world location, this one right here. There you go. You want to make sure it's world location and not relative location or something, because we don't want the cone relative to its parents. We want where the cone is actually sitting in the world as our starting location. Okay. So next, what we need to do is we need to track, I'll delete these real quick. We need to do our sphere on component begin overlap to see if our player has entered. So for this, I actually am, when I explode, going to want to use that launch character again, so we'll need a reference to a character. So I will go ahead and cast the actor that is overlapping our sphere to our BP third-person character. Cast to BP third-person character. I'll take that third-person character, and so far, I think I've mostly shown creating variables over here, but you can also just create variables in editor at any time by dragging off a pin. And then as long as you have context sensitive checked off, you will see this option here, which says promote to variable. And all that does is just quite literally a shortcut for doing the exact same thing I would have done if I created that variable manually. So I will name this variable follow target. Zoom into that so everyone can see, is Is everyone good with that so far? I know I'm going quite, like a little bit faster than I did with the other blueprints. Okay, cool. All right, so we have our starting location. We have the actor we're going to move towards, and we're detecting when we're entering it. So, sorry, when the player is entering and is now in our explosive cones aggro zone. That wasn't supposed to rhyme. But now, similar to the moving platform, we're going to have the actual move functionality on tick. But just like before, we're going to set tick as disabled as default. So we're only going to turn tick on when we're actually moving to the character. So we'll go tick enabled, just like before when we have the base blueprint selected, and we'll click start with tick enabled, set it to be false. And that way, when the player does enter the aggro zone and we do have a follow target, then we can set it to true. The actor tick enabled, set it to true. Cool. Right. So go ahead and add some comments here, and we'll say player entered aggro zone, begin moving to player. I just mumbled that, I realized while I was typing. Player entered aggro zone, begin moving to player. Okay, so once tick is enabled, we want to start adding our logic to move to the player. Now I could, something I haven't done yet, I could just start like building out in the graph, but kind of a safe practice in blueprints is things get really gnarly and unmanageable when you start adding a bunch of nodes straight into your event graph. So what you want to do is, just like you would in kind of like regular code, I guess, is start breaking things down into things like functions and macros, sometimes collapsible graphs or secondary event graphs. Nobody really uses those, mainly functions and macros. So instead of adding our logic kind of out here, I'm going to go to our functions category over here, click plus, and I will name this move bomb. So now we have a new graph that you'll see just kind of showed up on a tab up here. It's our new function move bomb. And if I go to our event graph and we plug up move bomb to event tick, now on event tick, we can call that function. And in here, it can have its whole own graph that is separate from what's actually in our event graph. Oh, promoting the to variable. Yeah, it's just a shortcut. So I can make a new variable by clicking this. Like I could make a new follow target. I could type out follow target 2, and I could go to the variable type, and I can make it a type DP third person character. And I can select this, then I can select this, and now I have a variable that is exactly the same as this. What promote to variable does is it's just a shortcut to do that. If I take something and I take promote to variable, then it says whatever the value of this is, go ahead and set it to be a new variable. In this case, I don't know, follow target 3 if we have a third one. It's quite literally just a shortcut. I could do the exact same thing typed and then go in here and set that value to be the thing coming out of our cast anyway. Oh, if you do not see that option, it is because you have this box unchecked. You want to check off context sensitive, and then you'll have it listed here. Sweet. Alrighty. Yeah, so now we're at like the really nitty-gritty part of this graph right here. You all can do it. I believe in you. The move bomb implementation. And let me just double check with the answer key to make sure I'm doing everything exactly the same as what you all can reference later. So I'll put some comments here. But the first thing we want to do, we're going to want to check, is the player, don't worry about what I'm doing right now. I'm just like gonna add the framework so you can kind of see what we're doing before we just start stringing stuff together. So we want to check, is the bomb chasing the player? If it is chasing the player, then we want to follow the player. And if it's not chasing the player, then we want to go home. It's going to go back to its starting location. In follow the player, we have two different things. You could either be chasing the player, or you could be blowing up on the player if you're player-seeking bomb. So we're going to have another branch up here. And what we want to check with this one is going to be, am I close to the player? I can't see you behind the Google Meets thing. There we go. Am I close to the player? Okay. If you are, so if you're not close to the player, then you can continue chasing the player. And if you are close to the player, then you're going to explode. And that's going to lead into there. And then we also want to check over here, did I get too far away from the player? But like these kind of 3 states are the base, or we're either going to be exploding, chasing the player, or going home. So we will start with, is the bomb chasing the player? For that, I'm just going to go ahead and create a new Boolean variable. We're going to call it B is chasing player. Let's switch that type Boolean. B is chasing the player. It's going to be false by default, if I have my default value when I compile it. But as soon as we enter the aggro zone, then I'm going to set it to be true. I'll do that before the actor tick is enabled. Cool. Now, inside of the move bomb, we're going to check if you're chasing the player, get that value. So at first, like when we first get the aggro zone, this should be true. We check, okay, the bomb is chasing the player. And then what we want to check is how far are you from the starting location? Because if it's too far from the starting location, on the next tick, we want to stop chasing the player. We're going to do the starting location, and we're going to do the distance to the current location. Now, to get the current location, I could, in fact, just like do get actor location and plug this in here and get the actor location itself. But we're going to need this a few different times, so I'm actually going to promote this to a variable over here. All right, get actor location, I'm going to drag off of it. And this time, instead of clicking promote variable, I'm going to click promote to local variable, which essentially is just a variable that only exists inside of the context of this function. It's nice for blueprint organization. You want to just, like, if you, for some reason, you made everything regular variables, then this list over here would start to get really, really long. We want to make sure like that doesn't happen, and then the stuff that only exists for this function stays within the context of this function. So we make it local, and now if I go out to the event graph, you'll notice it's not there. But yeah, that, not in the event graph. All right, I will name this current location. Set our current location to be the current location of the actor on event when we call a move bomb. And then I can use current location and get it just like I would a regular non-local variable and check the distance between the starting location and the current location. First distance, like I want to check, is how far away have we run from the starting location. I'll make a new variable for that. We'll call it max follow distance. And this one is going to be of type float. So let's say the bomb can run, I don't know, we'll say 2,000 units or maybe 3,000 units away from its starting location before it has to turn back and go home. So we'll default our max follow distance to be 3,000 units. Now, if we get the distance between starting location and current location, we can check, is this distance greater than, yeah, sorry, I'll do it the other way around to match the answer key. Is this distance less than the max follow distance? And you have you just type in less than, you have that node here to do like a map operation. Okay, if it is chasing, so we'll plug this up as well. If it is chasing the player, then we check how close it is to the player. If it is past the map, sorry, If it's less than the max follow distance, then we can continue to chase it. If it's not less than the max follow distance, then we need to set chasing player to false. And that way, next time this function is called, coming around, we'll go down this path instead, and the thing will start going home. So next we check, is it an explosion distance? So I'll do another branch here. And for this one later, now we actually need to look at the follow target. So I'm going to get our follow target of where we're trying to go, the player. And same thing we were actually talking about at break of like because this is a reference to an actor, we don't know if this is like valid or not potentially. So you want to do a is valid check. The thing with this is there is actually a shorthand because this is such a common thing to do. If you ever get a object reference as a variable, you can right click on it and there is a convert to validated get. Now this node is quite literally just a shortcut for this. Like it's the exact same thing. We can just do it in fewer nodes. A little bit easier. So we get our follow target, check if it is valid. If it is valid, then we're going to get the actor location of this. And then we're going to promote this one to another local variable. So and call that target location. Okay, I didn't mean to put that before the branch add. We get that first. Okay, once we have the target location, just like this before, we can look at the distance between our target location and our current location. Where is the bomb right now? Where is it trying to go to? What is the distance between those two? And if the distance is less than whatever distance you want the explosion to go off at, in this case, I'm going to go promote this one to a variable as well. So this will be the explosion distance. If it's less than the explosion distance, and let's say that one is like, I don't know, 150 units, 150 centimeters. Right. If the distance is less than the explosion distance, then you're going to explode. I'm just going to put a reroute node there as a placeholder. And if not, you're going to continue chasing the player. Okay. I know I'm going fairly quickly. So does everything there so far make sense to everybody? Yeah, it's cool. I'll zoom in here so you guys can all see the graph. Now this is like the one big graph we're getting to. And put some more comment boxes around here. I set mine to be 150. This is going to be in centimeters, so you can kind of set that to whatever you want. If you want it to wait until it gets like, I don't know, 100 centimeters away, you just want to make sure you leave enough room for like the mesh because like there's going to be a limit on what it's colliding with there. I mean, sorry, a limit isn't what's colliding with. It's like it'll never be in the exact same location as the player. It'll only get kind of close. Is valid check kind of the same as a null check? Sort of. So if you're talking like the C++ equivalent of like checking if something is null or null pointer, is valid does a little bit of extra stuff on top of that because like a pointer can still be like not null, but it's not necessarily like a valid in terms of Unreal's system of managing U objects. So it's sort of the same, and in blueprints we're going to kind of treat it like it's the same because it's the only option we have. But in usually in C++, you'd only use is valid like if you really need to, and a lot of times you just check like is this pointer null or not. Is the branch node deciding if the value is higher or lower than the set variable? So both of these, yes. Like if we use, in this case, we're looking at the distance between the starting location and the current location. So that's going to be wherever, I'll make it in purple. We're looking at wherever this guy has run to and wherever he started at. We're looking at the distance between these two. And then we're checking if it's less than whatever we say is the max follow distance. How many units can the cone go away from where it started? I set my max follow distance to be a default value of 3,000 units, like 30 meters. If it is less than that distance, then, like we haven't gone too far away, then we continue doing what we're doing. If it's not less than, and that's false, then we have gone too far away, and we want to set is chasing player to false. So yeah, it's like you kind of have it. It says returns true if A is less than B. So alrighty, now I'm gonna go on to like the next part where we actually chase the player and we actually explode. Yeah, so the less node is just making the comparison of like seeing like, is this number less than this number, true or false? And then the branch node is saying, okay, we should split the logic based off of whether this is true or false. So yeah, exactly that. Cool, right, so going on to the explode and the chase player. For the explode, I'm not going to put it inside this graph because we called this function move bomb. I'm going to make something different. For now, we'll just put a placeholder. I'll go out to the event graph. And we've talked a little bit about the built-in events here, with the built-in events relative to our components or just to our actor like tick and begin play. But we can also make custom events. So I'm just going to type in custom, and you will have this add custom event option right here. I'm going to click add custom event, and I'm going to name it explode. And all explode is going to do for right now is it's going to print a string that says explode. And we'll make, I don't know, I'll make it last for 6 seconds and it will be red. We'll add in a particle effect and actually like kill the enemy here after. But first, let's just like put a placeholder. This is where we're going to put our explode logic, and then we can go back to the bomb. So I'll go back into the bomb and the move bomb function. And from here, I can now call that event we just created. If I type in explode, you'll notice it's right here in this list. We can call it. It's an event that is part of this graph, so I can just, the target is just ourselves. And we can say if the bomb gets less than the explosion distance to the player, then we're going to explode. Cool. Now for the actual chase player part, we're going to use a node that is surprisingly like straightforward for what you can do with it. Set actor location and rotation. We're quite literally just going to like say this is the new location and the new rotation of our cone actor to get it to chase. But because we're running it on tick, we can actually do some like pretty nice smooth updates here. So set actor location and rotation. What the new location is going to be, I'm going to interpolate between my, oh, I still have these duplicate variables here, my bad. Between my starting location, oh no, it's not starting location, sorry, my current location and my target location. So the target location is the location of the player, the current location is the location of the bomb right now. And to get a smooth interpolation between these two, I'm going to use a node called vinterp2. And it's not a quick, straight linear interpolation. It's going to give us kind of a nice smoothing effect and a nice fall off. So that's why we're going to use it here. But we're going to interp from current to target, and that's going to be our new location. For delta time, we're just going to plug in our delta world seconds. So the time in seconds, the change in time since last frame. And for our interrupt speed, if it's, so you'll hover over it and it'll give you a detail. If it's 0, then it's going to instantly move to the target. We don't want it to be instantly moving to the target, so I'm going to set this as 2. And that'll give us kind of like a nicer, smoother sweeping motion. Cool. I'm also going to go ahead and turn on sweep here for collision stuff later. Okay, so that is going to set its location. Next, we need to determine its rotation. And in order to do that, so let me draw a new picture right here. Where we have the cone and we have the player. We want to take the direction from the cone to the player and make a rotation off of that so that our cone turns this way and is pointing to the players, like it has a, I don't know, pointy missile pointing at it or something. So we can do that similar to before. We take our current location, we take our target location, and we're going to get the unit direction. We get the direction from our current location to our target location, and then we can convert that to a rotator by using make rot, which stands for make rotator, rotator from Z. And that'll be so that the up vector is like facing the player, and we're like pointing the cone at the player. And I'll plug that into our rotation right there. I'm just making sure I didn't do anything differently in the answer key. There's a few small differences, but it's not too bad. So now if we test that out real quick, I'll go back to the level. If I walk towards this, it should start following me. And whenever it gets close, it should start printing explode. So, okay, we only have a few minutes here, and I want to make sure we have time for any questions. So what we might have to do here is actually cut off this blueprint here, but where you can find the rest of it is in the project. If you go to the answer key folder, inside the obstacles, we're going to have the BP demo player seeking bomb, and we're going to have the rest of the graph in here. And if we go and move graph, you can just find the last bit of the implementation, which is going to be the move back to starting position when you're not chasing the player. So I will, just for like demonstration, copy this in here, but I feel like, sorry guys, I was trying to get as much as I can into this workshop, but we compile that. Essentially what it's going to do though, is once we're done chasing the player, then when tick is enabled, we're going to start moving back from our current location to our starting location instead of the follow location. We don't, in order for this interpolation to be nice and smooth, each tick, we don't want to send the bomb immediately back to where it started. We want to do a small like increments of it. So in order to do that, the target isn't going to be directly the starting location, but it's going to be 300 units in the direction to the start. So direction from the location back to the start, multiplied by 300, and then add that onto that location to get our target location, and then getting the rotation the exact same way as before. The last thing that is going to be involved in setting up the, let me go to the original graph, is going to be the actual explosion itself and destroying the actor. So we would make a new function, call it, let's call it boom. I think that's what I named the other one. We'll replace boom with our print string. And inside of the here, this is the logic for boom, where we're going to spawn a particle effect. We're going to, I did not get into traces at all. It's hard to cover a lot in the time we have. But we're pretty much going to trace we're going to look for the player around the bomb. If we find the player, we're going to launch the character. And then after we do that, we're going to destroy the bomb. And I want to make sure I'm doing this on time, so I'm afraid we can't actually go through that part. But that is all there in the answer keys folder still. But yeah, okay. So that one would be like the last obstacle. You can get that one working. And then the one that I kind of knew I wouldn't have time to get this one at all, but it is in the project for your reference. If you'd like to go through it, is something that instead of just dealing with one actor has multiple. It is our bouncy ball spawner. And what it does is it just has a set like bouncy ball class where it uses something called a timer. It's spawns them every certain frequency. Once they're done, after a certain lifetime, they get recollected by the spawner in a pool, and then they get spawned again throughout that timer. And that one's a little bit more advanced than the player-seeking bomb, but it's, I'd say, around similar level. If you want to see all of the blueprints working together, the answer key also has a level folder in it. I have so many versions of this blueprint now, where you can kind of get all of the obstacles acting together. So we get the moving platforms, the bouncy balls falling everywhere. Oh gosh, I fell. The spinning platforms. Oh gosh, I'm dying at this right now. Let's move the players start up here so we can actually get the enemies working. Okay, there we go. And the player seeking bombs. But yeah, we are right at time now. So if anyone has particular questions about blueprints or whatnot, I can go through that. But I don't want to hold you all up too much. I really, thank you so much for showing up to this and going through some blueprint stuff with me. Yeah, we'll end on this slide. Yeah, thank you, everyone. Resources I'd recommend to start playing around. Let me compile a list after this because there are a few set tutorial series out there that I think are really good. I need to double check on some of them to see which ones are up to date and which ones aren't, because I'll admit I think the things I would recommend are like from 4.22 or something. But I will make sure I put a list together and get that to you all afterwards.
Quick question. Any resources for somebody who's jumping into Unreal and blueprints with absolutely no C++ or coding or math background, like pure art?
So, okay, I think my opinion here is a little bit not what most people would recommend. Some people say like, oh yeah, blueprints is a great context for learning more like programming fundamentals or C++. Okay, they probably don't recommend that C++. But I actually think it's almost better to learn some of this stuff outside of a game engine, because I think learning it alongside of Unreal can muddle certain concepts a little bit. The channels I recommend in particular for those just kind of like programming fundamentals, like if you just go through a very basic video series or course in that, and then translate that to Unreal and blueprints and C++ later, is one, something called processing, actually. If you look at the YouTube channel, The Coding Train, I think that guy has a really great introduction, especially for anyone coming from the artist perspective, because it lets you learn all of your I guess a lot of programming fundamentals while doing it in a way where you're essentially creating procedural art and doing it in a visual manner. And then for jumping into more just code in general or C++, I really like the YouTube channel Caleb Curry. I think he approaches things at a nice introductory pace for people who don't necessarily have a CS degree. I'll type those two in here, actually. The Coding Train and, sorry, Caleb Curry. Those two YouTube channels I think are very, very useful. How much is knowledge of C++ important? I'd say it depends. It depends on if you're trying to make a game jam game and a prototype, or if you're trying to like make an actual game you want to put out onto Steam or something. And it depends on what type of role you're going for. Like obviously someone who's a gameplay programmer has to know C++. Someone who's in a semi-technical role, like a technical designer or technical artist, I'd say like 50%, maybe 75% know C++, and the other 25% only know blueprints. But yeah, and if you're just want to do like, I'd say more using blueprints for artistic purposes and stuff that doesn't necessarily have to be super performant at runtime, or you're just like trying to create visuals for rendering or something, then just using blueprints is totally fine too. It's once you get to the point where you're comfortable prototyping something in blueprints, where I'd say it's nice to go ahead and jump into a little bit of C++, because that will just kind of open you up to that scale of building past the prototype stage. it's not bad. Like you don't have to just dive into writing all of your code in C++. There's something called blueprint function libraries, which essentially let you create a single node at a time. Like a node you want doesn't exist, you can create just one node in C++ and then do everything else in blueprints and bring in that node. And I think usually that's the best introductory way to get into switching back and forth between C++ and blueprints. And then once you're used to that, then you might do something where like your parent class is in C++ and then you make a child class in blueprints and start slowly doing more and more of your logic in code.
Also, apart from coding, do you think any like a strong background in math or physics is crucial for somebody who's going for like a technical art or more on the art side of blueprints?
Okay, yeah. So for tech art specifically, I'd say, oh gosh, there's actually a few different resources I recommend. Let me grab a list. So not all of us have time to take a whole linear algebra course and a calculus course and whatever else you need. So I really, really like the book called Math for Game Devs. And you're like, why would I go to a math textbook? That's a bit excessive. Like nobody just straight up reads a textbook by themselves. But this is a textbook that's available free online where you can in fact read it by yourself and go through it. And it is incredibly useful, even if you don't have an instructor. Apart from that, there's the 3 Blue, 1 Brown series on linear algebra, which doesn't give you enough knowledge to actually put anything into practice, but it gives you kind of a high-level overview of linear algebra from just like outside of outside of game engine concepts. I'm trying to type here and I have a cat sitting on my keyboard. So that list right there. But then if you want something that's fairly thorough, and I think especially good for tech art in particular, then I would recommend Freya Homer's Math for Game Dev series, which I think pretty much her whole series, all the assignments, assume you're working in Unity, but you can do all of the assignments in Unreal. You just have to like refuse to use some of the built-in stuff so you can learn it from scratch. Let me grab a YouTube link. She has a lot of these series. I don't know which one is most up to date, but the Math for Games Devs there. Pretty much if you've gone through those 3, then I think you're for the most part all set on like maths you would need in Unreal.
Yeah, that's an exhaustive list. Thank you so much.
Yeah, no problem. I recommend this exact list a lot because I think for a lot of people going to tech art, myself included, at one point, they're like, oh shoot, I had a degree in like arts, or I don't have a degree in this at all, and now we're doing a lot of mathematics that isn't necessarily covered in school. I guess it depends on what country you go to school in and where you're based. But I find in high school in particular, a lot of people, for some reason, just go straight through algebra and into calculus and never touch linear algebra, except for like, oh, by the way, vectors are a thing one random week in the school year. And then you get into the work field and linear algebra is like, so you get into actual working and linear algebra is everything. So yeah, I guess if that is it, if you all have like any other questions or questions about the project files or like lose the link to it, you can find me like both on LinkedIn or on Discord. I'm in the Sierra Division Discord in there, and just ping me. I think you have permission to ping me. But yeah, thank you so much for coming to this. I'm glad to share the passion for blueprints with other people. Okay, yeah, thanks everyone. The recording will be up soon, and I will see you all around.